the physics of color. Now, the reason I'm doing this is I've watched a lot of videos with folks talking about colors and what colors are. What is the color white and the color black? What is red, white, and blue? This is very hard to do without presentation materials, and there's enough other videos on it out there that you can find well done materials. And after you've seen about 40 of those videos, you might begin to piece together what these folks are talking about. I think I did, so let's give it a try. Our eyes contain cones and rods. Most people have heard of that. That's what detects the light we see. Those cones and rods, one of them detects white light. Basically, white light. I'm going to explain white in a bit, but so that's what one set of detectors in your eyeball does. The other set detects colors, but it only detects 3 colors, 3 hues. And if you have certain genetic anomalies, some of those hues don't come through the same. But because you see a color and you've been told the name association with a color, your mind can make up that difference, so you name most colors the same, but some challenge you. So your eyes have a range of colors that they can see that is different than the range of black and white that your eye can see. So if that doesn't confuse you, try to think about how your mind would process eyeball information. But that's not what this is about, other than your eyes are how you interpret, how you see, how you define and speak about color. So when you see a blue, you say blue. Or a red, you say red. And you can get into magentas, and you can get into pastels, and there's so many colors that you can do. What your eyes are seeing are wavelengths of light. The color receptors see actual wavelengths of light. I'm going to use that word frequency with all the woo stripped from it, because that light has a wavelength, which is a frequency, and that's what those little molecules in your eyeball respond to, is specific frequencies. And they say, hey, red's here. There's a lot of red here. The whole eye's seeing red, so your lenses are focusing onto that little retina, which is much more interesting than a CCD, camera, your cell phone camera. But from that, you go back into some table, some bag of colors in the back of your mind, and you say that's blue. Because you were taught the word blue, and the association was just built by the nature around you, humans around you, right? The reds, the blues, the greens, the yellows. Like I said, I like pastels, so there you go. So how do we have labeled colors? We have very mostly specific, although in languages it's different, right? Because they have different names for the same colors. So there's that variation. But in science, there is a range of frequencies that we see as colors. There is a range of energies that we see as colors. And the intensity of those gives us basically a number to our brain, and the brain says blue. So how does a computer interpret this? Well, when I was growing up, we started with printers and black and white or black and yellow screens. So you didn't have a lot of colors, but you had an ASCII character set you could play with. So see a lot of folks playing ASCII, basic ASCII, extended ASCII. So the evolution of the computer character set, I'm among them, has been tedious and plodding. But there's color interpretation. Where does it matter? If you're painting cars and you want to verify that the color you bought in that can matches for all the cars you're going to produce across the planet, then these colors, these things matter. So inside of that, one of the color scales is called a Pantone scale. The Pantone scale is the color scale, but it is defined out much more precisely. It's based upon those wavelengths of light, the specific mix of light wavelengths that make up a magenta, a turquoise, those other things. And then you add a complexity of other minerals in there, so they're sparkly. How do you look at a sparkly blue versus, so this is cameras and imaging. The camera, CCD, works in sort of the same way as the eye, but it only provides an array of numbers. The array of numbers the computer reads and puts into tables or into quantums, little sums of packets, so it's quantified over time to make this pixel blue or that pixel red. Depending on the sample rate of the camera, there's all kinds of software in between you, me, and the CGI you're looking at that does massive amounts of interpreting a number into a color to put on the screen. So I mentioned that I worked with ASCII character sets, and we had line paper and printers, so you could print banners using ASCII character sets in the good old days, because that's what you had. Now you can go get a printer that will, or whatever. So the color tables, the display of this evolved. One of the first graphics sets I worked with was Regis Graphics, developed by Digital Equipment Company, and it was, in its time, almost a standard in industrial control system displays. We had a custom language, proprietary language called Dicel, which you built schematics, display schematics for cracking towers and reactors and compressors and generators, and displayed them to an operator, and in this case you had 16 colors to use. So in your evaluation of color usage for discrete components, you had to worry about what colors you would turn those vessels in the case of emergencies. In the case of not an emergency, but a tuning issue. So it's a little out of control, but not a lot. So it should be yellow. It should be something between green and yellow. But can an operator see that or visualize it? Where are the numbers displayed on that graphics display? So this was a little bit of color interpretation, considerations just for an operator. You have 3 shifts of operators staring at computer screens for 8 or 10 hours a day. You want to make sure that the displays are meaningful, useful, and aren't computer games as well. So a lot goes into building those colors. After that, automotive industry color mapping, vision stations, vision cameras, CMM machines doing measurements, dimensional measurements, process measurements. So these cameras use these same types of techniques. They simply get a number back per pixel of resolution that the camera can scan at a frequency or a rate, and then software interprets and interpolates all that. This is the basis behind those software models that show you the future weather forecasts, fundamental display graphics and systems. So how do you present a production line to an operator, in what colors, and to management in what colors? These things have grown and migrated and gotten improved and better and more expensive and less expensive. It's part of the presentation of the real world through this video medium here, right? You know, that you're looking at. So it comes back to photons, which is the bulk of what we're looking at, which is a discrete energy range inside of many different energy ranges that we know about on the planet. So there it was, all made easy in hitting 10 minutes here. Maybe next year we'll start doing some presentations, give you some ideas. These are concepts. 201. Introduction into the things, the pieces that tie us all together, and some well understand. Thanks all. Have a grape day. Maybe have some bananas with those grapes.